AP Chemistry, what should you memorize? Well, several topics. You should know what elements exist, you should know what ions they tend to form, and you should know those charges. You should also know your polyatomic ions, since this is a common lingo of chemistry, and I often find that students struggle there. They don't know what a nitrite is. They don't know a nitrite from a nitrate from a nitride, things like that. You got to memorize them. So that's what we're going to do right now. In the second part, we'll cover a few other topics, including solubility, but less solubility than you might imagine. The AP Chemistry people do not require a detailed knowledge of solubility, and that is a common misconception. And we'll also mention, even though it's not strictly required, the organic chemistry functional groups. Okay, let's dive in. I have some elements here. Tell me what the symbol is. Hydrogen, H. Helium, He. Lithium, Li. Now you might want to pause the videos and say them out loud yourself so that you can get them. I'll give you enough time to say them out loud. Let's see how you do. Beryllium, Be. Boron, C. Carbon, C. Did I say boron was C? Boron, B. Carbon, C. Nitrogen, just N. Oxygen, just O. Don't forget it exists as O2, but we're just simply saying what is the symbol. Fluorine, no, Fl is Florida, it's just F. Neon, Ne. Sodium, from the German natrium, Na. Magnesium, Mg. Aluminum, Al. What are the common charges? Well, maybe you saw that. Hydrogen can form either a cation with no electrons at all, or the hydride anion, -1. Helium, noble gas, nothing. Lithium, first column, +1. Beryllium, Bemca Cerbera, that's saying the entire column, that's the alkaline earths, +2. Boron, yuck, don't use that one much, +3. Balgantal, boron, aluminum, gallium, indium, tantalum, right? All those are +3, although as you get into the D block, it gets more complicated. Carbon, best off not doing it because it tends to almost always share, but you could say +4, perhaps -4, very rare. Nitrogen, NAPASB, nitrogen, phosphorus, arsenic, etc., tend to be -3. Oxygen, -2, fluorine, -1, and neon, nothing at all, noble gas. Sodium, first column, +1. Magnesium, second column, +2. Aluminum, third column, +3. Silicon, well, it has an unfilled D shell, so it can do some fancy things, but let's talk about the symbols first. Why don't you pause it, do the whole column, and see how you did. You should find that silicon is Si, phosphorus is P, sulfur is S, chlorine is Cl, argon Ar, potassium is K. A lot of students know that. Calcium, Ca. The ferrous metal known as iron is Fe. Copper, no, that's cobalt. It's actually Cu, not Co. Zinc, Zn. Lead is a plumbous metal, so Pb. Bromine, that gross brownish liquid, Br. Iodine, such a beautiful looking gray crystalline solid, I. Charges, silicon, cussy guessing pub. Carbon, silicon, germanium, tin, lead, +4 and -4, tends to share more often. Phosphorus part in NAPASB, so it is -3. That's nitrogen, phosphorus, etc. Sulfur, lots of different charges, and it is good to know them. For first year students, -2 is good enough, being just under oxygen, but we know once it goes in, since it has an unfilled D shell, it can do fancy things like +6 and +4. Chlorine is not only just -1, but this is the most common one. Argon is a noble gas. Potassium is +1. Calcium +2. I think the most common one for iron is +3, but it can also be +2. Copper, Cu, lots of different charges, +2, +1. See, we're showing some of the polyvalent metals. Zinc, believe it's in that what's called the diagonal, and it only goes +2. Aluminum +2, aluminum +3, zinc +2, silver +1. Lead is +4 and +2. Bromine is typically -1, and iodine is typically -1 as well. Be aware that the halogens can do fancier things. I think that's enough. Let's do part 2 in the next slide.